right, some more additional formulas. So first, summation of I from 1 through n is n times n plus 1 over 2. Second, summation of I from 1 through n of I squared is same as n times n plus 1 times 2n plus 1 over 6. And summation I of 1 to n of, if you add I cubed, this is n plus 1 over 2 squared. Now, there are geometrical proofs for this, which is good to know, especially for the a and b. But I want to show you a method to prove these identities without using any geometry, just pure algebra, because that also is helpful. So let me pose a question, and my goal is to prove this first part for today, and then next time I'll prove the second one. You have a question? Yes.
Does that say for b it's divided by 2, or does that make 6?
Divided by 6. This is 6. Okay, so we're just going to prove A for now, and next time we'll prove B. Question: if there's a sequence of numbers AI, where I is from 1 through n, if you add up the first n sequence of numbers, these sequences add up to n squared. If this is true for all n 1 or greater, question is, what is AI? Well, it looks a little mysterious, so let's think in terms of examples, then we can work on the generic one. So let's say we have sigma of I from 1 through 3 of AI. According to this formula, what should this equal to? This formula says what?
N times n plus 1.
No, we're gradually getting here, so we can't reference this.
So
you can't reference what you're trying to prove, okay? So don't do that.
Okay.
Yeah.
We're going to add AI 3 times. Or just do AI.
Okay, so this has a meaning, right? What does this mean? Left side?
A1
A1
plus A2
A2.
plus A3.
That's what it means, okay? But this is given. What does this imply?
That
It
says
should equal to?
n squared.
What's n here?
That's
3.
the 1
3.
squared.
So you should get
9.
3 squared, which is 9, right? Okay. What about when you set n as 4?
3, 16.
This should equal to
16.
4 squared, which is 16, right? Now, given this, see if you can figure out what A4 should be. Yes?
4a.
No.
It's 4.
No, A4 is not 4.
4 squared.
No. Don't guess. Make a logical conclusion. Yes. Nope.
The cube.
Is it 2?
No, don't guess. There should be. All right, let's start. What does this mean again?
Summation.
The summation from
Sum
1
of the
to 4.
ordinary.
So you have A1 plus A2 plus A3 plus A4 equal to
16.
16.
But you asked about A4, which is
What is A4?
Oh, it's
No.
So it's 16 minus A1 minus A2.
4a, A4.
Which is?
I'm confused.
No, come on. You're. I don't know what you're doing. You're just really trying hard not to get the
16
answer.
squared?
It is 4. It's 4.
No.
Is it 16 squared?
No.
Why are you making guesses where it's like obvious way to get it? If you have A1 plus A2 plus A3 equal to 9, and A1 plus A2 plus A3 plus A4 is 16,
Oh,
then
it's
A4 should
five.
be not 5?
Or seven.
Seven,
Sorry.
7.
You have to add to get to
Because 16 minus 9 is 7.
This much adds up to 9, this much adds up to 16, so what is this? This must be 7. This is 9. 9 plus 7 is 16.
There's two separate summations.
I see what you did.
Right? A4 must be 7, right? Okay. Now let's see what this is saying. What if we have A1 through A5 added? What should this equal to according to our condition?
5 squared.
Which is 25, right? This means that A5 must be
25 minus 16.
16.
9. 9.
Oh, well, it's up. Oh.
Must be 9, right?
Stack.
Get it? I feel so sorry for people who don't get it.
Why would you, when you're asking for A4, why would you go back to the old summation instead of sticking with the one you just made?
The thing is, these are numbers that don't change. You're assuming that A1 through AN for infinity, they're fixed numbers. And they have this property that if you add them up, it gives you n squared. So maybe that's the confusion you had. You thought that every time you write this, these numbers change. Okay? But what this was saying was that they're fixed numbers, where if you add the first 3, you get 9. First 4, you get 16. So what's the fourth number? It must be 7. That's what I'm saying. Does that clarify? All right.
Yes.
Good. Got it? Okay. Now, let's see. Now, the actual solution. Think about what summation of I equals to 1 through n minus 1 would be if you had AI. What would this equal to? Well, it's the same formula. What's the only difference between this left side and this left side? N is replaced by n minus 1, right? So the right side must be?
N minus 1 squared.
Yeah, n minus 1 squared. What is n minus 1 squared? It's n squared minus 2n plus 1. Just FOIL it out, and that's what you get, right? Okay, then, what would be an then? The same kind of argument, right? How do you get the an? You think about the sum of n terms minus the sum of n minus 1 terms. Sorry, this should be ai. Right? So what do you get? This should be n squared minus n minus 1 squared. So if you do this minus this, n squared cancels, and you're subtracting, so those become negated, so it's positive 2n minus 1. Now, what does this mean, though? This means that if you take these numbers, so the answer to this ai would be this is 2i minus 1. If you start from, what do you get if you plug in 1 here?
1.
1. And what do you get if you plug in 2? 3. What do you get if you plug in 3? 5. Do you get 9? Really? Add the first 3 numbers. Do you get 9? Yes, you do.
Yeah.
Right? This is 3 squared.
Oh, it's 2.
So the interesting thing that we figured out is that if you start from 1 and you kept adding all the odd numbers until 2n minus 1, you get n squared. And that actually has a geometric reason why. It's another interesting thing, but we don't have the time to explain. However, I want to use this fact to figure this out. So how do you actually get this? Well, think of it like this. You have summation. So this result says if you add from 1 through n 2i minus 1, you should get n squared, right? Now, using the properties that we talked about the sigma notation, we can split this summation I equals to 1 through n of 2i minus summation I from n of 1 is equal to n squared. All right, tell me what this is.
1.
No, you're adding 1 repeatedly, right?
Oh,
So what do you get?
1 times n.
1 times n, right? So this is 1 times n, right? This is 1 times n. So I can move this to the other side, and that becomes n squared plus n, right? On the other hand, we also learned that if you have a constant in front, we can bring it outside the sigma, right? So if 2 times sigma I from 1 through n of I, you get this. Okay, why does this prove this?
Well, because if you factor n out, you get n parentheses n.
Yes, you can factor the n out here. And then all you have to do is divide by 2 and you're done. Okay. That proves it. Okay? Now you can do the same thing with n cubed. Okay, so that's what we're going to do next time, and then you can just continue on and prove all these other forms.